For those of you who came along, it's great to see you all here, and hopefully you will find this interesting, and I'll be delighted if you've got lots of questions for us at the end. Hopefully it will be of interest to you all. Sometimes it takes the eyes of the world and a catastrophe upon you to affect change, and on the 24th of April on 2013, so almost exactly 2 years ago from today, the eyes of the world were firmly upon Bangladesh. Bangladesh is a very young nation. It was formed out of a bitter conflict and a civil war with Pakistan in 1971 at the height of the Cold War. It's a population of around 160 million people. So that would put it in the top 10 most populous nations in the world. The Global Human Development Index, which measures things like health and education, income, it ranks Bangladesh at 146 out of 187 nations in the world. So clearly it faces many challenges. It is particularly politically unstable at the moment. There's industrial unrest. It faces many urban poverty issues, increasing urbanisation, and it's highly vulnerable to climate change. So they do face a lot of challenges in Bangladesh. Dhaka is a city of around 15 million people in an area just under a quarter the size of London. It's one of the most densely populated cities in the world. And for those of you, and some of you in the audience know I've been there, it's an incredible place with easily, I can say easily, the worst traffic jams I've ever seen anywhere in the world. The garment industry was seen by Bangladesh as a way out of the chronic poverty, and the development of that industry has really taken place at a pace which is quite phenomenal. It is now the second largest garment manufacturer in the world after China. Over 4 million people in Bangladesh work in the garment industry, mostly women. About 80% of the employees are women. It has exports of 20 billion US dollars. So that represents 80% of the country's exports. So clearly the garment industry is absolutely fundamental to the growth and development of this nation. The biggest customer, if you like, for clothes from Bangladesh is Europe, at about 70%. The US follows after that. Arab first became involved in Bangladesh. In the end of 2012, there were a number of fires in large factories in Bangladesh, and one of our long-standing clients, they were called Inditex, a Spanish garment company, asked us to give them some assistance and some advice on how they would go about carrying out fire assessments and assessing the evacuation from factories as a result of those fires. So we were working in Bangladesh just when Rana Plaza collapsed. So over 11,030 people were killed in the collapse, and clearly many thousands were injured. What you can see there is the remnants on the day after. You can see 4 stories. Originally that building was 9 stories. The top 5 stories were completely obliterated, and they were fully occupied during the collapse. Clearly it was a time of great chaos and mayhem and devastation for many people. It makes it one of the largest and greatest industrial disasters in the history of the world. So it's instructive at this point to look into a little bit more, why did this building collapse? So you can see from this graphic, you can see that the building was originally designed to be a 5-story building. And then an additional 4 stories were built, and not only that, they were in the process of building another story when the factory collapsed. In addition, not only were they extending vertically, they were also extending horizontally. You can see on the left-hand side, a very large cantilever And none of the columns at the lower levels were designed for that increase in load which they were subsequently or experienced. The building itself had multiple occupancies. At the lower levels there was a bank. The bank, and in the days leading up to the collapse, there were reports of structural issues, and people heard loud noise like gunshots, and people became worried about the columns. Cracks developed in the columns, and some people were sent in to assess those. The bank workers were all sent home, and the garment factory workers were unfortunately all sent back into the factory. So the response, and our first involvement in the structural issues, as I said, was through Inditex. You probably are familiar with Inditex through Zara and Massimo Dutti and lots of other shops that we see all over this country. And I think, as I said, they are probably the second or third largest company in the world in the garment industry. And after the collapse in Rana Plaza, while we were already helping them on fire issues, they came to us and said, clearly we have a bigger issue here. It's not just fires. We don't know what is the condition of the structural condition of the factories where we are currently buying our garments from. And the objective that they set us was to provide assistance. They weren't quite sure what it would be. They were very open about whatever we developed, whatever we found would be shared with all of the other factory owners and the other garment manufacturers. So we were very clear about that at the outset. And so they very much drove the agenda and the response in the post-Rana Plaza days. Inditex were a founding member of what started off with the EU retailers and an organisation, an umbrella organisation called the Accord. And it's considered by those in the know in kind of corporate social responsibility sphere that the reaction of the garment industry here in Bangladesh was a game changer. It hasn't been seen anywhere globally. And the Accord itself is a legally binding agreement signed up to currently by around 190 garment manufacturers. In addition to those garment manufacturers, on the oversight committee, there are global trade unions looking after the workers' interests. And you also have the International Labour Organization, who are an arm of the United Nations. And just some of the key points of the Accord, which are very interesting. It's a legally binding agreement, so once those garment manufacturers sign up to it, they are bound to it for 5 years. And what they have to do for 5 years is that they have to help finance the inspections which we've undertaken. Following that, they are contributors to a fund which is about $100 million US dollars, and that fund also supports the factory owners in carrying out the necessary remediation works. It established an inspectorate on the ground who would coordinate the efforts of carrying out a minimum level of safety inspection in all the factories. Transparency is a huge issue. All of the factory information will be shared, our findings will be shared, and we'll touch on that a bit more later. And they were also very much collaborating with some of the other players in the factory business over there. The Accord covered, as I said, it's 190 brands. We're familiar with very many of them. I apologise for the poor quality, but clearly you can see that we were all connected in some way. It's unlikely that any of us do not have a piece of clothing that's made in Bangladesh. We're all connected to this in some way. What this slide tries to show is both the interrelationship. The Inditex were our first contact in Bangladesh. They were a founder member of the Accord. The Alliance is a grouping on a similar, slightly different, but a similar basis to the Accord, mostly made up of US factories, US garment companies. And they cover a certain number of factories, so approximately 600. The Accord cover approximately 1,100. The balance of the factories in the country are being inspected under the auspices of the government. So the government being supported by the ILO to carry out those inspections. It gives us a round number of somewhere of the order of 3,500 factories in Bangladesh, all of which will have a minimum level of safety inspection undertaken. Our supported the Accord in a number of it's very long and I suppose harmonisation talks really between the three parties, and to come up with a harmonised and a unified approach to carrying out this. And the methodology that Shane is going to go on to describe that we developed in the early days has now actually been adopted nationally. So all of the factories are now being inspected in accordance with the methodology we developed. The other areas, so our assessment our methodology was structural based. We also gave a lot of advice on fire. And then the other area which has been inspected is electrical safety, which has led to a lot of fires. It's one of the contributing factors to fires. And one of the key issues in all of the work being undertaken by people was to find a balance between critical life safety issues, so making sure that the workers are safe, but on the other hand allowing the business, which is so fundamental to the economy, to continue. It's a very difficult balance, and we'll talk more about the challenges we faced through the project on that. I suppose one other point on the harmonisation talks, there was an agreement there on what would be the approach where a factory needed to be closed, and we have seen that unfortunately, but again it's been done for life safety issues. That's the fundamental part of what we undertook. So Shane's now going to go on and talk to you more about the methodology and the implementation of the programme.
So our first task in Bangladesh was to survey 120 Inditex factories, and to do this obviously we needed to come up with some sort of methodology. Inditex were very keen that methodology that we undertook for their factories would go on to form the basis of the methodology that the Accord undertook, the Alliance undertook, and that the rest of the government factories were inspected too. So obviously, us being structural engineers in Ireland, we had very little experience of what was happening in Bangladesh. So we set about a fact-finding mission to try and find what were the construction techniques used in Bangladesh, what was the engineering profession like. So we tried to gather all of the knowledge we had internally and externally to come up with a methodology. One of the key documents we used was the I/T appraisal of existing buildings. So what did we find? Well, what we found was that in general, the buildings were comprised of concrete. We found that in general the garment factory buildings were 3 to 7 stories high. There were generally beam and slab. Sometimes we came across flat slabs. They were, for the most part, moment frame connections between beams and columns. We generally didn't find that there was the lateral stability was provided by shear walls or cores. And there was quite a bit of variance between factories. They varied from something like you see here, there's just one building entirely occupied by a garment factory. We also found other factories where the bottom 2 stories were comprised of markets, or other industries such as we saw in the Rana Plaza case, there was a bank or other activities going on at certain levels. There was some exceptions. There was some factories that were comprised of single or multi-story steel structures, and these were probably the exception. A very small percentage of factories fell into this category. But what we did find a bit more often was that on the roofs of RC buildings there was small, normally non-engineered steel structures. And then as well as that, we found that adjacent to the main factory building there was often a steel structure that served as a warehouse or for more heavy industrial activities like the washing or the printing of linen. So as we have seen, concrete is one of the major building materials of these garment factories, and as we began to dig into the construction of these buildings, what we found was that more often than not, brick aggregate had been used instead of stone aggregate, as we'd be used to in Ireland. And it happened for a number of reasons. One, because Bangladesh has very few natural quarries, and so a lot of the stone would have to be imported, which meant quite expensive. Another is that Bangladesh makes a part of the delta and had a lot of access to clays, which could be dried and fired in the kiln to make the bricks. The bricks were then chopped up or chipped up, as you see in the picture on the left, and added to the concrete. In general, there's a very small ready mix industry in Bangladesh. Most of the concrete is site mix. As Aidan was saying, the 3 and 4 hour traffic jams don't lead to a very healthy ready mix industry. So what we did find was that the concrete was very variable. We found that in a lot of cases the grading of the chips wasn't very good. We found quite large chunks in some of the cores that contributed to the concrete strength in a negative way. And so what we set about doing, obviously we needed to get an understanding of what this concrete, an average of the strength of these concrete. So we collaborated with some of the technical universities in Bangladesh. We got some historical cylinder and core data, and we were able to start to compile a database based on those results. Out of interest, the concrete strength, cylinder strength for a brick aggregate was about 14.1 newtons per millimeter squared, and the for stone was 16.3. So that was from our analysis. That was the statistical, the numbers that we came out with at the end. Obviously, as the project went on, we were able to revise our assumptions based on as we got more data from more buildings. So our methodology then, as we developed our methodology, what we came up with was a visual plus survey. So this is mainly visual, but in addition to that, we did some calculations. What we thought was important in considering was everyday gravity load. We didn't review seismic loads because most of the buildings would have failed had we done that. But what we decided was that columns were the critical element, and both for a number of reasons. Columns were the element that failed in the Rana Plaza collapse. Also, we felt that whereas beams and slabs can be a lot more ductile in their failure, columns can be quite brittle, give very little warning. So it was obviously of concern to us. We developed a working stress methodology, and this is in line with international best practice. We were able to reduce the load factors based on the certainty that we had going into factories and seeing what was on the ground and seeing the exact, measuring the exact depth of slabs and so on. Just to reiterate, we were really interested in the life safety of the workers in the factory. We weren't trying to make these buildings code compliant to any degree. So I suppose this approach then that we came up with the colour coded scheme based on an overall factor of safety onto the columns, and these colours fed into the colour designation that we would assign the factory at when we issued the reports. So as part of our methodology, as part of the development then, we carried out some field tests on 6 factories in Dhaka. Initially, it was thought that about two factories could be surveyed each day with reports, and this quickly became very unrealistic given the traffic jams, the difficulty finding factories, and just the sheer size of some of the factories. But as we surveyed 6 factories first, and as we went along, we were able to upgrade and refine our methodology. So just to talk a little bit about some of the tools that we used while we surveyed the buildings. We had a specifically designed RF Inspect app for the project in Bangladesh. This is an iPad-based data gathering tool. So it basically allowed us to record all of the information that we found at one of our visits to the factories. It was particularly useful in that we were able to take pictures of floor plans and then be able to locate pictures and notes to certain parts of that floor plan. It was very useful because, as you see in the next couple of slides, we were doing quite a few surveys per week, and after a couple of weeks out there, they did all seem to blend into one a bit. So it was very useful to have something like this to be able to have it clear as we went to write the reports. So the colour coding, as we spoke about, fed into the overall colour assessment for a particular building. So the columns were one part of the colour coding, and we also anything else that we found from our visual inspection would have fed into this colour coding as well. So we came up with a kind of traffic light system whereby if we deemed the factory to be red, it was the factory must be closed immediately. Amber was immediate action was required on some part of the building. For example, empty water tanks or remove high loading from cantilevers, for example. And yellow was some action within 6 weeks, and green was normally that the building is generally okay, and that was maybe some longer term maintenance issues that we wanted to be addressed. We also had another tool that we had at our disposal was to call for a detailed engineering assessment, which we generally called for if the colour coding was amber or red, we called for a DEA, and this was a more in-depth study of the building, analysis of the building, and normally carried out by a local engineer. But I suppose at the heart of the methodology was that this is a very pragmatic approach to the situation in Bangladesh. It was the objective was to prevent another Rana Plaza, and we couldn't go in and condemn every building based on code compliance, and it would have a disastrous effect on the economy, which is vital to the prosperity of Bangladesh. So to take a look at a typical working week, so we generally went out for 3-week stints. We aligned our working week to the Bangladeshi working week. So we started our work on a Saturday morning, bright and early. So we surveyed about 4 factories per week, and we had 2 report writing days. So we had half a day to write each report. So we work 6 days a week, as they do in Bangladesh, in the factories. So we maintained a team in Bangladesh of about 30 people. About half of these were from Arab worldwide, and about half were local Bangladeshi engineers and project managers. So we were also supported by the survey teams that went out to the factory were supported by a PM team that we had located in Dhaka, and we also maintained a team in our ARP office in Dublin, which was able to review and advise on the reports that we were going to issue. So our team consisted of a lead structural, or a lead surveyor, and normally a chartered engineer with some experience, such as Aiden. There was also a support engineer, which were also from RF Worldwide, which likes of myself with a few years experience. And we were also we also recruited some local Bangladeshi engineers. So these were generally 1 or 2 years qualified, so quite useful in aiding us with the survey for gathering the huge amount of data that was involved in these surveys. I suppose also we wanted to make sure that they got something from the experience as well. So we wanted to leave them with a good experience, and learn from the process. And many of the engineers that we work with have stayed in the process. Many are working for the Accord now, or are working still in Bangladesh as engineers. We also have one of our local support engineers has joined our office in Cork and is studying part-time down in Cork as well. So as you can see from the photo as well, we were often accompanied on these surveys from quite a few factory managers and spectators, who were always very interested in the tools we were using, which I'll talk about in a few minutes. But there was normally a big cohort of people following us around, and it did seem to dwindle slightly just before lunch. But apart from that, they were omnipresent. So to start to explain what happened on a typical day we went out to survey a factory. We generally arrived at the factory. There was a lot of times where the journey took a long time with the traffic, and the address system in Bangladesh wouldn't be the best. So it normally took a bit of time in the morning to find them. When we got there, we got out of the car. We normally met with a factory manager or factory owner, and we then proceeded to walk around the perimeter of the building. And of course, this was to give us an overall sense of what was in store for that day. So we were looking for some basic information. We were looking for how many stories there was. We were looking for was there a lot of external cantilevers, what overall size was the building, and if there was more than one building, what extent were they, what condition was the facade in, and was there a clear phasing of the construction. We then proceeded to go up to one of the meeting rooms and have an interview with the factory manager. We generally did have to maintain a bit of a healthy skepticism for what they told us. Often they were trying to tell us what they thought we wanted to hear, but nonetheless we found it very useful. A lot of them would have been around during the construction of the building, so it was quite useful. We also asked for any documentation that they had, so any permit drawings, structural architectural drawings, site investigations, and so on. Again, we had to, we got a big variation in what we received in documentation. In certain cases, we were handed a perfect set of structural drawings and building exactly as they were drawn. In other cases, maybe the bay might have been the same, but the bay dimensions might have been the same, but there might have been a couple of extra bays or a couple of extra stories. And in other cases, we were given plans for a different factory down the road, so they were not quite as useful. And again, I suppose in terms of site investigations, I was handed one day that was dated the day before the survey took place. So we had to, I suppose, again, just maintain a bit of skepticism. We then started our visual inspection. So we generally started from the roof down, trying to follow the load. We took note of the bays, the measurements, the layouts, the movement joints, and so on. We were particularly interested in areas that looked like they were under distress, or areas of high loading. Often these rolls of denim are quite heavy and they're quite low on the slab. What we did have to do as we walked around was remain very sensitive to the workers that were there, and we were going in during their working hours. They were working away. I suppose there was, because I suppose we were on the ground so quickly after Rana Plaza, there was quite a fear still among workers about building safety. So I suppose we had to be a little bit discreet in the way we took notes and pictures to ensure that they weren't getting overly worried. What we did find as well on the walk-arounds was that the people over here are generally brilliant plasterers and painters, and so as you've seen with the brick chips, it can be quite a rough concrete, but the render they put on them, it can make them look immaculate. And often we went into factories smelling of fresh paint, and some factories there was a bit of a joke going around that painters were only one floor ahead of us painting over the cracks, so again we had to be very vigilant. So to run through a few of the tools that we used during our surveys, we used a ferromagnetic scanner. We generally tested a couple of columns at ground floor level with the scanner, and it gave us an indication of the amount of reinforcement. And normally we could, if there was structural drawings, we could compare the two. It gives a very good indication of the number of bars, and the bar size a little more variable, particularly because the render was sometimes quite thick on these columns. We normally chipped away, and we always removed the render and chipped away at the side of the column to expose the aggregate type, which again, as we've seen, is quite important, fed into our calculations and made a big difference to the concrete strength. We also used a Smith hammer on the concrete, and this didn't directly feed into our calculations, but it was more of a comparison tool that we were able to use. So I suppose it was important to note that this isn't your typical survey in the structural surveys that we do in Ireland. Oftentimes the factories were massive. I think I hold the record of visiting the biggest factory in Bangladesh, which was a long day. It was about 60,000 square meters, and there was about 16,000 people working in it. So it was more like a small-sized Irish town rather than a garment factory. So to move on then to the report, what was vital for us was that the reports were very clear, very visual. So as you can see from the screen, this is an example of a cover page. We've only included a picture of the building. Obviously there's so many, and so it can be very close together. We included GPS coordinates, which again, because the address system isn't great in Bangladesh, it was a vital tool for being able to capture what factories we had surveyed. Very clearly on the top right hand corner then we see what colour designation we gave that factory, in this case amber, and we also made it very clear that this report calls for a detailed engineering assessment. So I suppose it was very important to us that these were very graphical. They were very graphical presentation or reports. They are all available now on the Accord website in English and Bengali. So anyone with access to the internet can go and read them. And we wanted to make sure that if any layperson or non-technical person went in to look at these reports, that they would be able to understand what the critical issues were. This is an example of one of our observation slides, and what we found in this case is that the loads were too high on a portion of the slab, and we advised that all of these, all personnel and would be removed from this area, and we clearly indicated the extent and dimension. At the end of the reports, then we set out our actions and clear time frames for which they had to complete these actions by. As it indicates on the screen, the immediate action was to empty the water tanks, and then subsequent actions normally call for a building engineer to do a more detailed analysis of what we have found. So I'll pass back to Ed now to go through what we found from the project and finish up.
So just as I suppose to recap on the timeline, I said it's 2 years now since Rana Plaza collapsed. So in that 2-year period, Shane said pretty quickly we were involved in developing the methodology. So that was in the summer of 2013. We then went on to do around about 120 surveys for Inditex at the end of 2013, just into the start of 2014. We were then appointed by the Accord at the start of last year. And from March until July, we carried out 446 factory surveys for them. And we're currently finalising a final tranche of factories for them now. So we got another, it's at the moment, up to today, it's 172 factories between January and today. So it's about 750 factories that we've surveyed, that we've walked around, that we know a lot more about now than we did before. And it's been very interesting. It's unusual for us to gather so much data across and to create such a big data set. And it's been very, we've learned a lot from it. And so in terms of the findings, what this just shows, I suppose, the overall color coding. And if you just think of the color coding as urgency levels, because it's all time bound. So red factories, so factories that needed to be closed. Out of the factories that we surveyed for the Accord, less than 2%, actually just under 2% of those factories needed to be closed. So that's 11 factories. And it's worth saying that was our recommendation. It's not easy to get a factory closed because that affects thousands of workers. And I'm glad to say that the factories either have been closed and vacated, or they're working under quite strict, reduced operational parameters. For example, 2 or 3 stories are out of action, or there's very large areas which are no longer in use. And the Accord safety inspectors, part of their role is to follow up on that. So, like that 2%, I suppose, in some ways it's reassuring, is that not every factory is a Rana Plaza. And maybe we all go with certain preconceptions about what these factories are going to be like, but it's quite a small number that are, I'm not necessarily saying that they would have been a Rana Plaza, but they had all the hallmarks and the risk indicators. Now the flip side of that comment is that 45% of the factories are in the amber zone. So that means there's immediate action required in almost half of the factories. And based on this data set, you can say that means almost half of the factories in Bangladesh need immediate action, which is a huge undertaking for the whole industry, for the country as a whole. And what we just wanted to point out here were, I suppose, what I talked about earlier, key risk indicators. Now, knowing now what we know after doing so many inspections, there are certain things that we know that if you put them together, there's a high indication that you're going to have some structural problems or structural issues. So there's certain things. If a building is between 5 and 7 stories, if it's built before 2005, and in particular if it's built before the year 2000, if it's built with brick aggregate, all those things put together mean that there's a high probability that that building may have some structural issues associated with it. If you ally to that, you go to a factory where there's no structural drawings, there's no permit drawings, or they're very poor quality, they're not representative of the as-built situation. It's another risk indicator. And then there's 2 other associated things. What we found in many factories were that for the general column, which is just picking up floor loading from general factory areas, those columns could be what you might say okay, acceptable. But if those columns were also associated with edge cantilevers, which were not necessarily in the original design, if they were associated with carrying areas for toilets, water tanks, or as Shane said, some of the storage areas, the denim rolls, those kind of things, then it was as if those columns weren't designed for the functions which they ultimately ended up carrying, the loads that they ended up carrying. And that was, I suppose, became quite clear to us over the last 18 months that it was just a really clear risk indicator. Now, they're kind of generalities, but you know, when you've got a data set of 750 billion, you can see that there's quite a lot of truth in this. The Accords work goes on. Instead, you can go to their website, you can download the reports from any of the factories that have been inspected. So there's a very high level of transparency to what they are doing, which is, I think, is quite commendable. And as I said earlier, it is considered to be a game changer in terms of the garment industry is quite closed and secretive. So this openness and transparency is a whole new venture globally, and Bangladesh leads the way in that front. So what does the future hold for the industry in Bangladesh? There are a lot of roadblocks in the way. There's a lot of obstacles, but there's no alternative to this approach. The economy depends on the garment industry in Bangladesh so much that they cannot afford, for many reasons, they cannot afford another Rana Plaza. So there is now an acceptance that this has to be done. So the preliminary inspections need to be carried out, the remediation effort needs to be completed. And I suppose from a personal view and a personal experience, in 18 months I have actually seen the culture change, if you can say the culture changes in such a short period, but I have seen attitudes change, perhaps. It's a better way of saying it. Perhaps when we went there first there was more defensiveness, there was more resistance to the work we were doing. And over time, people, being the people who own the factories, the politicians, have realised that actually it's vital, it's necessary, and it must be done. And that what follows on, the remediation efforts, that has to be followed through. The Accord has a 5-year timeline. It's 2 years into that now. The objective is at the end of 5 years, you'll reach a business as normal scenario. Just a normal building a factory, having a normal lifespan for that factory, moving on to another factory. It's quite a tall order and it's quite a challenge. Whether it'll reach it in that time period, who's to say, but what I would say is that it is going in the right direction. So another couple of points I'd like you to remember is that the people we've been working with, our clients, so, and I would say that garment manufacturers do not have a great name, but people like Inditex have driven the agenda, have driven this change in the mindset, and they are to be commended. And you can say, perhaps there might be cynical reasons for why they have done that, but they're very committed to not just doing a whitewashing exercise. It's not just about getting 3,500 factories and having a preliminary inspection. For them, it's more than that. And the Accord likewise. They are following up on the actions that we have noted in our reports. They are now going through an extensive detailed engineering assessment phase. There are remediation works ongoing. So they're very committed to that. I suppose we would hope that the work we've done here can contribute to making a safer working environment in Bangladesh. And not just in Bangladesh, but also further afield. And we're starting to see that. I came across a couple of months ago an article about Vietnam, which is also one of the great global garment manufacturing countries, and they've recognised this issue of structural safety, and they have adopted the same methodology on a trial basis. But they say, we would like you to do assessments in some of our factories. Can you do it in the same way as you do it in Bangladesh? So I suppose that's reassuring that this has got a wider appeal. And I suppose for our own staff and our colleagues, our response was quite significant. It was supported globally within our own organisation. We had over 100 people who visited Bangladesh. The project team as a whole is probably upwards of 130 or 140 people in quite a short period of time. Those who went there had to work very hard. Like let's not hide from that. It's a tough, challenging working environment. It takes you outside your comfort zone, and the day you walk into your first factory and you think back to Rana Plaza, it makes it very, very real. But for all those people, almost universally, I think people have come away from that with a very strong sense that they've made some contribution to making a difference. And it's not very often, it's not always on our projects that we get a chance to do that. So for all of those people, I think, and certainly from my own experience, I've got a lot more out of this than I've put in. And so from that point of view, it's been a very rewarding project. At this point, thank you very much.
Wow. I'll talk to you later about all my shocks to the system I heard as I went through. I'm going to open for questions, but can I ask a question first? Can you tell us a bit more about the permit system? So
Yeah.
How does a building that's designed, and you talk about structural drawings, so obviously an engineer has been involved, for 5 stories suddenly get added an extra 4 stories and no one complains?
I think that's it's a really good question, and when I answer it, you can also think of, could this happen in Ireland?
Yeah.
So there is a planning system, the permit system. So each building that gets built gets a permit, and that permit will have a very light touch structural engineering involvement. It might have a typical column design, on a drawing. It'll have general arrangements, maybe one column with some rebar in it, just to show you intent. Now, what happens after that, in some cases, is that the design develops no further than that, and it gets built. And sometimes people will say, well, maybe we could just add another story. No one is going to come and inspect, so there is no follow-up. They don't have the capacity. Up until last year, there were about 50 inspectors in the particular ministry who would do this for a country of 160 million people. So it's just, there is no follow-up. Permits are, corruption is an issue, and you're talking about people being paid very small sums of money, professionals being paid very small sums of money. So if somebody comes along and say, well, can you give me a permit, can you sign off on this? That is natural. It doesn't happen all the time, but undoubtedly it does happen sometimes. So the permit system is there, but it's really a fig leaf. It doesn't reflect reality. It also doesn't reflect every factory and every building. And I always tell the story of, I was in a factory where they make 100,000 pairs of jeans in an 8-hour shift. So it's the biggest denim manufacturer in the world. Now you don't get to be that size by kind of getting somebody to fake a signature on a permit drawing. These are serious businessmen operating a serious industry. But it's a very broad spectrum. Mm-hmm. So the permitting is of questionable merit in that it doesn't get followed up afterwards. And I suppose that when I started my response, I said, well, think of Ireland. And I suppose that when we look at our own issues in recent years, and maybe maybe this wouldn't happen specifically around the plaza, but we have had our own issues in certain areas, and the building control regulations and the changes to that reflect that. So we can look outwards, but we can also learn something, I think. Yeah. So hopefully that answers your question.
Okay, questions from the back?
I have 2 questions that I would be interested in. I actually worked out in the Philippines and in Vietnam.
Yeah.
And I certainly have seen plenty of those areas.
Sure.
But the first question is, what would the income for an equal-sized column built in the British Isles, same height, extra height, what would the ratio of the strength of that be to a brick-built one? And the second question is, if there is a serious earthquake that affects that, what percentage of the buildings will be significantly structurally damaged?
Okay, there's two very good questions in there. I suppose they're questions which have occupied us for months. To answer your first one, the brick, in terms of just pure concrete strength, it's about 15% weaker. And also the reinforcement is like our own move from mild steel to high yield. They've had that's come a lot later, so that has contributed to. I'm not sure I can give you a like for like answer, but in terms of concrete strength if I was to measure one versus the other, you are talking about a 15% difference in the masonry aggregate concrete. What I would say in general, their structures their structural elements would be smaller, and you've probably seen this in places like the Philippines and Vietnam, where slabs, we would never do a 140 slab spanning 6 meters, but they're all over the place in Bangladesh. We used to say, if you went into a factory and you saw a column that was 280 by 280, which wasn't uncommon, you knew you had a difficult day ahead of you. So because the elements are smaller, clearly material cost is much higher. On the second issue, Dhaka in particular is very sensitive to a seismic event, unfortunately. We have done some work in this area, and to be honest, it's kind of a ticking time bomb, in that there would be devastation in the city and the country if there was a serious seismic event. And that the code has only recently their code has only recently recognised I suppose the importance of seismic and adopting seismic design parameters. So that's the code, but as we've seen, not everyone gets designed the code anyway. So you also have non-adoption of the code. So unfortunately, it's a very serious situation.
Just on the seismic issue, I did come across something in the Bangladeshi code whereby it's actually you're not allowed to build a flat slab because obviously when a beam and slab structure collapses, that it gives you some area to hide in between when it collapses, whereas a flat slab is obviously going to be completely devastating for anyone who's there.
Okay, yeah.
Just one question I had is, what comes next? Like, I mean, it's probably outside of your remit, but just we say new builds, are they better engineered, better constructed, or are we still going to have the same problem in 10 years where we're going to have to go back and do more surveys?
I think that in general we found the new builds to be better. I mean, we saying that before, it was built before 2005, that was a real, and before 2000 again was really serious problems. There are good new builds, and what they're influenced, they're beginning to move out of the city, to the outskirts of the city. There's a bit more space, and we're seeing some quite well developed, custom made, properly designed factories. We visited one factory, which is a 23-story tower, so it's bigger than Liberty Hall. It's just a garment factory, brilliantly designed, and in fact, it sounds like a big factory to inspect. We probably got it done in a very short period of time because it was really well built. So there's definitely an improvement in the new building stock. We'll say that. What's happening now is that those detailed engineering assessments and the follow-up, they're ongoing, and we are involved. Actually, Inditex have asked us to help them, I suppose, evaluate the quality of, because it doesn't make sense to have Arab or any other Western firms come in and do thousands or hundreds of detailed engineering assessments. Just the finances of that, and also in terms of supporting the engineering profession there, that doesn't make sense. So it has to be driven by the local engineering profession. So it's actually very positive because it elevates the role of the engineer there. So they're ongoing. Imitex have asked us to come in, and we're following 4 DEAs currently, and we'll do a verification of the steps that they've undertaken to make sure that we're happy that they're doing it in the right way, they've got the right approach. So that's ongoing right now. And then there are some remediation works already ongoing in factories. So it's you're talking big numbers, and it will take time, but bit by bit, it is improving.
Just one more question, if you don't mind. You spoke about the Bangladeshi code. Would say, in terms of comparing that like for like with the Euro codes, would it be of similar standard, or is there need to be improvement made there?
No, it's quite good. Like there's a 2006 version and there's a 2013 draft version. It's actually quite a good code. It's modeled principally on the US codes. It's actually quite good. So if everyone designed to it and designed to the new version with all the seismic stuff in it, then you'd generally say that great. That would give you a resilient and robust building structure. So it's not a code issue. It's getting people to, especially the people who are spending the money, to realise that they're there for a reason.
Thank you.
In the factories you went into where you found the red and even the amber conditions,
Sure.
did you find that the factory personnel, like the management, seemed to be almost aware of themselves, or were they blissfully unaware?
That varied. There would be, I suppose, for a lot of these people, like they're garment industry, so they're not civil or structural engineers. So for them, we've been in this building for the last 10 years. My office is right over there. Why should we close? So that there would certainly be, we would have found a lot of resistance from them at times. And then I'd say there would be some who would be more, I suppose, savvy or realistic and kind of go, well, we can hope it will be okay. And over time, as the whole, since Rana Plaza, and over time as they've seen how others have reacted, there's more, that people were more like, please tell us that our building is okay, please help us, we want this building to be okay. I do sit in an office over there, I'd like the building to remain standing. So that kind of resistance or kind of head in the sand probably changed a bit, but it was quite fraught in the early days. I've never worked on a project where you do a survey today and tomorrow you'd be in the papers about you've been to this factory and it's going to be closed down, and the guy who owned the factory is an MP and very heavily politicized. And so you're working under those pressures as well, but so trying to keep the focus on what was important, where it was, it was very important to us.
Okay. Gentleman in the grey jumper and then the check shirt. Sorry, you, sir.
Right, okay. The codes, this is United Industrials, so we've been thinking in 5 kilonewtons per square metre.
Yeah.
What did their codes require, and when you estimated the actual loadings, were the average loads per floor that you took? Okay,
the code over there, they have light industrial and heavy industrial, and the code loads are similar. They're not dissimilar, and they would be banded, so it might be 3, 5, or 6, and depending on subcategories. So if you were to go code to code, you'd say it's quite similar. We probably do the same here. What we actually saw were probably loads of 2 kilonewtons per square metre or less. Like most of the areas were like sewing machines and people. Most of the areas, and so when if you weighed up all that and you were in or around 2 kilonewtons per square metre, and that I talked about the harmonisation of standards earlier. That was taken as the minimum level that you checked for. Now you'd also, if you came across an area which had floor to ceiling denim rolls, then you worked out what that was specifically for that area and checked for that. What we did find, which was really interesting, and again, this was all about refinement and learning as you go along, where actually toilets had a huge amount of dead load because they're squat toilets. They're built up off the floor with of maybe 400 or 500 mil of a build-up, with the drainage then in that build-up and then taken out to the wall. So when you actually weighed up all of the build-up in the toilets, plus all the partition walls, all built in masonry, we frequently found that was where we had problem areas, because you had probably smaller columns because they were right out of the corner, or they built a cantilever and the toilet was sitting out on the cantilever. So we frequently found problems in those areas. But in general they're not that heavily loaded. It's just very specific areas which you'd flag up as an issue.
Yeah, you mentioned earlier about lateral stability, and that you assumed a lot of them, or maybe you actually made able to determine somehow that they were moment frames rather than concrete cores. How do you determine moment capacity of a frame that you don't know what the rebar is?
Yeah. I mean to be perfectly honest with you, like our assessment is just purely, it just assumes it's just purely gravity load, and because there is some of the factors that go in to make that load factor safety deal with kind of out of plumbness and moments going into columns. So we didn't, I would say, specifically calculate it because there were so many unknowns there, and you have a day to go in there and make a judgment. Well, what we did, I suppose, it was engineering judgment. If you went into a factory and there were, if you identified that there wasn't a clear lateral stability system there, or that you had some question marks about the robustness, you would make what you might call a macro assessment of that. You wouldn't get into the numbers of it, but you would kind of raise it as an issue to be dealt with as part of the detailed engineering assessment. And it's a difficult thing to do. You can go in and do more work, and you could probably work out the capacity, but could you get through the volume as quickly? Probably not. And so that's a really difficult balance. And we use the analogy of, in emergency medicine, we talk about triage. So when you go to casualty, you get triaged. And that's what we did for about 3,500 factories. Is that you go in there and you see, okay, which of those factories do we pass through to the emergency ward, or which could wait here for a little bit longer? So that was, we know that there are deficiencies, if you like, in the preliminary assessment. It's not ideal, but it gives you, it gives you some sense of confidence about that building, and then make a judgment about whether it should close.
Is the risk from cyclones or that sort of thing also as large as it would be seismic?
It is actually, yeah. I mean, in Chittagong, one of the second city, the design wind load in the code is 260 kilometres an hour. So if you work it back 2 hours, it's 3 times higher than ours. So wind loading is a huge issue. So I suppose you're absolutely right. Cyclone loading is an issue, but it's all about thinking of the day-to-day loading, and then thinking about the lateral stability in the overall sense, either for wind or seismic, and making pointing out a deficiency in that if it was sufficiently worrisome for us.
We'll take one more question then.
You mentioned about life safety, your total life safety aspect, and the fire and electrical.
Yeah.
Did you have members of the team doing that, or was that different?
It was different firms. We were involved in on the fire front in terms of setting up what would be done, and then there was a Korean firm and a US firm who actually did those inspections. So there were and they were done separately. So we'd go along one day and do a structural inspection, and maybe next week you'd have the fire, and the week after the electrical. So
Because some of the spaces are very big, and there's no suppression systems, it obviously threatens your structure.
Absolutely, absolutely. So there was all those issues. Now, I suppose what, if you like, what was comforting for us is that, you know, we could do our structural inspection and focus on the kind of issues we talked about here, safe in the knowledge that either the day before or the week after, you had another series of fire experts who were coming through making exactly those issues. You know, you need to have suppression systems, you need to have fire doors, you need to compartmentalise. So I suppose we had that level of comfort, if you like, in that it was being considered. Because otherwise, you're right, if we were doing it in isolation, there'd be a lot more issues we'd be, you know, highlighting, blocked fire exits or huge compartments, all that kind of stuff.
Great, thank you. There's a wide range of questions. I'm going to call on Eddie to propose a vote of thanks.
Okay, as a member of the Engineers Ireland Construction Division, I've been asked to propose this vote of thanks. I suppose a couple of things I have to say. Naturally enough, it's been an excellent presentation. You can see there was a huge challenge, and a big part of that was the level of judgment I think required when you're not working to specific codes, where you can't just tick those boxes. It's much more difficult. And then getting the balance between the requirement to save lives and the requirement to keep the economy going was a huge thing to land on anybody's shoulders. It's a long way away, but something like this really brings it home and shows us that we all have a responsibility to make sure there's never going to be another, or hopefully won't be another Rana Plaza. And I think the level of transparency that you mentioned in relation to your findings, how you approached it, will go a long way towards that. So if I could ask everybody to show their appreciation in a normal manner.
Thank you.
Great, thanks for coming, everybody.